The computer guiding that spacecraft had 4 kilobytes of memory. The Instagram app on your phone doesn't fit in that space. The wall of the spacecraft was 0.012 inches thick. 3 sheets of aluminum foil. Drop a heavy tool inside it, and the spacecraft would tear open. And yet, in July 1969, 2 men rode that tin can all the way down to the surface of the moon. No advanced technology, just cold nerves, improvisation, and 18 seconds of fuel to spare. That landing cost the equivalent of $150 billion in today's money. It came within 18 seconds of becoming the worst disaster in the history of space exploration. The story I'm about to tell is not about Apollo 11's success. It's about how many times it almost failed and what kept it from collapsing. It all started with a beep. In October 1957, the Soviet Union launched Sputnik, the first object ever made by human hands to orbit the Earth. And it wasn't American. 4 years later, Kennedy made a promise before Congress to go to the moon before the end of the decade. Not because it was easy, because it was hard. NASA had 9 years to solve a problem that physics barely allowed to exist. The moon is 239,000 miles away, in a vacuum. No atmosphere to slow a fall. No room for error. The vehicle that had to land there was designed under one clear philosophy: every ounce counts. The result was a spacecraft that looked far too fragile for what it needed to do. In the non-structural sections, the wall was 0.012 inches thick, half a soda can. The mission's brain weighed 70 pounds and ran at 0.043 megahertz. A pocket calculator from the 1990s was more powerful. So is your TV remote. The software wasn't stored on any disk. It was literally hand-stitched. Senior seamstresses at Raytheon threaded wires through microscopic metal rings. One wrong thread was one wrong bit. One wrong bit could be fatal. For navigation, no GPS. They used a sextant, the same tool 15th century sailors used to align with the stars. On July 20th, 1969, the Eagle began its final descent. 12 minutes to landing. 2 men, a 4 kilobyte computer, and a dead rock waiting down below. What happened in the next 12 minutes entered the history of engineering. 3 separate systems began to fail. At the same time, the computer entered a data overload. The fuel began lying to the sensors, and the computer was steering the spacecraft straight toward a boulder field. The descent had less than 6 minutes to go when the first problem appeared. The rendezvous radar, a system that should have been off, started flooding the onboard computer with data. A computer with 4 kilobytes of RAM had no room to process anything that wasn't essential. Suddenly, a code nobody had seen in real flight blinked on screen. 1202. In Houston, flight controller Jack Garman, 26 years old, was the only person who knew what that code meant. Garman had studied every possible error code on his own, weeks before launch, just in case. The 1202 wasn't a failure. It was the computer saying, "I'm overloaded. I'm going to restart and keep only what matters for landing." That was only possible because a software engineer named Margaret Hamilton had designed the system with a priority architecture. She anticipated that the system could be overwhelmed. She built a survival protocol into the computer. The 1202 flashed 4 more times during the descent. Each time, Garmin said the same thing to Houston: "Go. We're go. Problem solved." But the second threat was already in motion inside the fuel tanks. As the fuel depleted, the empty space inside the tank grew. The liquid started sloshing. The level sensors read empty one moment and full the next. The computer was receiving false data on how much fuel remained. With inaccurate data and an overloaded radar, the computer plotted a landing trajectory. It aimed the Eagle straight at West Crater, a crater 600 feet across, ringed by boulders the size of cars. Armstrong looked out the window. He saw the rocks, and he made a call that wasn't in any manual. He switched off the automatic landing and took control of the spacecraft as if it were a helicopter. Every second of manual flight burned fuel that was already nearly gone. In Houston, flight controller Bob Carlton started counting out loud. 60 seconds of fuel. The dust thrown up by the engine nearly blinded Armstrong. He was flying on instinct. 30 seconds. Almost 98% of you watching our technical investigations are not yet subscribed to the channel. If you value this level of depth in engineering, consider joining our official community now. Leave a like so YouTube understands that serious documentaries still have a place here. Before we continue, if you want the Eagle on your desk, LEGO released the official replica of the Apollo 11 lunar module. Set 10,266. Real engineering in 1,087 pieces. The link is in the description. And in the channel's pinned posts, you'll find the best books and documentaries on the Apollo mission. Worth every page. Now, only 20 seconds of fuel remained. What Neil Armstrong did next changed history. The contact probes touched the ground. Armstrong cut the engine immediately. The Eagle has landed. In Houston, men who hadn't cried in decades cried. On the fuel clock, 18 seconds remaining. Had Armstrong taken the length of one YouTube ad longer, the Eagle would have fallen like a 50-foot stone. The Eagle was on the ground, but the mission wasn't saved yet. Hours after landing, Buzz Aldrin made a discovery that nearly prevented the return. The ascent engine circuit breaker was broken. A $1 piece of plastic. Without it, the ascent engine wouldn't fire. Armstrong and Aldrin would be on the moon forever. Aldrin used a regular ballpoint pen to push the switch and activate the system. A $150 billion mission, saved by a pen. The ascent engine had been designed under a philosophy that bordered on radical. What doesn't exist can't break. No spark plugs. No ignition system. The engine used two fuels that explode on contact. Open the valves. The engine fires. The fuel was pushed by helium pressurization, like squeezing a giant ketchup bottle. No pumps. No unnecessary moving parts. On July 21st, 1969, the engine fired on the first attempt. The ascent stage left the moon behind. During ascent, external temperature swung 540 degrees Fahrenheit between sunlight and shadow. What shielded the electronics was a golden film called Captain, the same material used in emergency thermal blankets. A thin polymer sheet standing between a 4 kilobyte computer and absolute zero. 7 minutes and 10 seconds after liftoff, the Eagle found the command module in orbit. 3 men, back together. Mission accomplished within margins that modern engineering still considers absurd. Apollo 11 wasn't a demonstration of technological power. It was a demonstration of how far engineering goes when it has no choice. Apollo 11 cost $150 billion. It involved 400,000 engineers, technicians, and scientists, and it depended on a software engineer who anticipated the unforeseen before anyone else did. On a 26-year-old flight controller who studied error codes nobody expected to need. On a pilot who ignored the computer, trusted his own eyes, and landed on the only patch of clear ground available. Those footprints are still there. The moon has no wind, no rain, no erosion. 1,000,000 years from now, if someone makes it out there, they will find the exact marks of where Armstrong stepped. The engineering of Apollo 11 was not perfect. It was resilient. Success didn't come from the absence of failure. It came from the ability to keep functioning while everything was failing. a computer that rebooted to survive, a pilot who improvised to land, a pen that guaranteed the return. That is the legacy of Apollo 11. Not perfection. The refusal to fail. If this video made you see engineering differently, the like is the best way to say so. It helps the channel keep bringing you this level of depth.